We'll proceed in sum series to integral calculus. Sum series to integral calculus in which we are pursuing the discussion. We are seeing traffic, not very high traffic, but we are seeing traffic in these videos. Sum series and integral calculus, especially the Fibonacci series, because first time people are seeing that Fibonacci series can be computed, can be summed up. So otherwise people were happy with the Fibonacci series itself, but Fibonacci series can be added. So this is what people are seeing now. We are doing discussion in Grandi series. There is a Grandi series, and Grandi series talks about 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on. Okay, the concept was to proceed in Grandi series in the left hand side area and central area. We are talking about successive approximation. In integration, we are talking about calculating the summation series. We are talking about calculation of summation series through integral calculus. And in this technology, calculating the summation series through integral calculus, we compute the sub-area region. There is something called sub-area region, and sub-area region is the base or pillar of integral calculus. Integral calculus works in calculation of area only. If you have so many area, you add all the area to have one area, and that area is coming under a algebraic curve. Then we can say it is integration of that curve. What do you mean? I mean, if I say I have 5 into x, 5 into x, then I can represent this as a graph where this is x-axis and this vertical is 5. If we see what everything in calculus is based upon this small concept of integration only. Everything. High class differential equation to everything based upon this basic thing only. If this is x-axis and consider that I have one sub-area, contiguous and non-overlapping sub-area. I have so many sub-area. What is sub-area? Consider there is a graph like this. There is a graph like this. If there is a graph like this, then I have an area from this point to this point and it goes and hit the graph. Then from this point to this point, from this point to this point, from this point to this point, I have sub area. If I add all the sub area, I get full area under this curve. Okay, if this curve equation is fx, then I can write as fx, that is the height, into width, that is x. Since height is not constant, it is changing with the x. We, rather than writing fx into x, because if I multiply height with the width, I get the area. But this area will not give because fx is changing. Fx is not a constant item. I can write as fx into x, width, and height gives the area. But this area is changeable with the x. So rather than saying fx into x is the area, we write fx into dx is the area, making sure that it is integral calculus. Integral calculus means calculation of the area. Okay, what is else? There is nothing else. Integral calculus means calculation of this area. How we calculate this area? Please watch our video as primitive calculus. Primitive calculus, there we have started discussion of calculation of complex area. This will come under complex area. Okay, if it is a flat line, like 5 into x, we started discussion. If it is a flat line, oh, doesn't look like a flat line. Consider this is a flat line, height is 5. Then I can calculate the area as 5 into x, because everywhere height is 5 only. Okay, 5 into x can be rewritten as 5 into dx as per the integral formula. Limit from 0 to x, that will come as 5x only. So integral calculus is nothing but calculation of multiplication of two items where one item is x-axis, one item is y-axis. Draw the graph, calculate the area and say this is your multiplication. Because calculation of area is also one way to calculate the multiplication, and that way integral calculus uses. And for them there is a one special case is when height is constant, that is 5 into x. Otherwise height may change with the x. That's why we say height is function over x. Anyway, can we use this fundamental that integral calculus is nothing but if I have a curve and if I calculate area underneath this curve, this area will give the summation of a series. Amazing, mind-blowing concept that we have invented. It is not available in any of the book that is called sum series and integral calculus. We are calculating for the Grandi series. So in order to calculate this, now what is series? I say, let's consider this is x-axis. Under this x-axis, I have x equal to 0. I'm sorry, x equal to 0, x equal to 1, x equal to 2, x equal to 3, x equal to 4. These are called slots. On x-axis, I have slots or I have x value. Under this x equal to 1, if I have a value, that value will go up like a vertical called function over x. So when x equal to 1, I have 1. When x equal to 2, I have minus 1. When x equal to 3, I have 1 again. X equal to 4, I have minus 1. When x equal to 5, I have 1 again, minus 1. This is called Grandi series, 1, minus 1, 1, minus 1, 1, minus 1, 1, minus 1, and so on. If all of a sudden, if I ask someone, can you calculate this summation? Out of the way, he will say 0. 1 minus 1, 0, 1 minus 1, 0, 1 minus 1, 0, up to infinite, yeah, 0. Are you sure? Yeah, 0. If I ask another guy, then he is very clever. Now he knows that first guys took 2 as a pair, then that person is taking 1 minus 1, 1. Consider the last one in infinite series is 1. Then answer is 1. So someone is saying 1, someone is saying 0. But Sir Grandi, he said no. The infinite summation is not 0, not 1. It is actually 1 by 2. This is what we prove. We will prove that Sir Grandi said correct, but we will now verify it through integral calculus. We have done it in one video that indeed it is coming as 1 by 2. So this verifies what Sir Grandi has said, that it will come as 1 by 2. Okay, we will try another way for the Grandi series. Then we will try many other ways also. So in this section, we will try another way. And what is another way? Another way is, consider this is x-axis. If this is x-axis, consider this is 0 and this is 1. This is 0 and this is 1. From 1 onward, when x equal to 1, I have height as 1. Now between x equal to 1 and 2, this is to show how actually we are doing using integral calculus to calculate the summation. How we are using integral calculus to calculate the summation. Now consider I have 0, 1, 2, 3 as x-axis, and between 1 and 2 I divide this into 10 parts. Consider, so that people understand how actually it works. From 2 to 3 again I divide into 10 parts. From 3 to 4 again I divide into 10 parts. Because summation of 1 minus 1 plus 1 minus 1 plus 1 minus 1, it does not think about what is x value and what is function over x value. We are trying to model it or mold it into independent and dependent components so that we shall be able to calculate it. But this is not the technology. In examination, it is written 1 minus 1 plus 1 minus 1 plus 1 minus 1 infinity. Tell me what is summation. Now we are saying, consider I have x-axis where x equal to 1, x equal to 2, x equal to 3. In between I have 10 parts. X equal to 1, x equal to 1 plus 1 by 10, 2 by 10, 3 by 10, x equal to 1 plus 10 by 10, that is 2. X 2 plus 1 by 10, 2 by 10, 2 plus 10 by 10, that is 3. Means between each x equal to 1, 2, 3, 4, I chop into 10 parts. Then I chop it into 10 different parts. Understandable? Now consider that I have fx. There is one guy called fx. Anyway, as we have described earlier, we have two sections now. One is, if I talk, one is all the plus are there. If anyone is watching Grandi series, then it is 1 minus 1 plus 1 minus 1 plus 1. There are 1 which is plus, and there is another category of 1 which is minus. Means I can segregate the full summation of full series into two parts. First part is 1, 1, 1, 1, 1, 1, 1. Another part is minus 1, minus 1, minus 1, minus 1. If I add all this and add all this and then add together, we get the summation. Okay, minus 1, minus 1, minus 1 will go and it will make a big minus 1. Plus 1, plus 1, plus 1, it will go and it will make big plus 1. Then we add both to get the final result. Now consider, if I talk about 1, 1, 1, 1, consider at when x equal to 1, we have first 1. Then another 1 will be at x equal to 1 plus 2 by 10. One gap will be there. If I see the position in x-axis where numbers are there, when x equal to 1 where we are starting, the next number will be at x equal to 1 plus 1 by 10, x equal to 1 plus 2 by 10, like that number will be there. This is to make things understandable in better way. So if I first number fx, that is 1, is at x equal to 1, next one will be at, after one gap, that will be 1 plus 2 by 10, 1 plus 4 by 10, 1 plus 6 by 10, like that, 1 gap. If I talk about minus 1, then first will be at 1 plus 1 by 10, next will be at 1 plus 3 by 10, next will be at 1 plus 5 by 10, and so on. Understand? Now consider that if I consider the 1 what we are seeing, and 1 is minus 1 minus 1 minus 1. This is x axis. This is function over x axis. If I take only positive verticals, then if I connect all the top point, then it will be a flat line. It will be exactly a flat line of height 1. This is a discrete function because it is sampled at various places. It is not a continuous function. What is the equation of this? What is the equation of this? Equation of this is 1 because height is always 1. Fx equal to 1, always 1. What I'm trying to calculate is sigma. Sigma sine x equal to 1 because it starts at 1 to n fx, means fx plus fx plus fx plus fx, last like that, where first x is 1, next x is 1 plus 2 by 10, next is 1 plus 4 by 10. At the end we have x equal to n. This is what I want to submit. Okay, let's consider there is another continuous function called gx. If it is a continuous function called gx, then if I have x equal to 1 and next is x equal to 1 plus 2 by 10, then there is an area strip that goes and hit the gx. This area strip, consider it has a value same as on left side whatever we have function over x, that is 1. Then next then fx equal to 1 is at 1 plus 2 by 10. There again we have vertical as 1. That vertical is same as area between 1 plus 2 by 10 to 1 plus 4 by 10. This area. What do you mean? I'm trying to say, if I take any x, then I have a function over x, and that function over x, that is a flat line of height 1, that will be exactly same as between x to x plus x to x plus 2 by 10. 2 by 10. If I draw area and go and hit gx I don't know, it is a continuous function. That sub area is exactly same as left hand side, fx at x equal to x. Fx at x equal to x is 1 only because everywhere it is 1. So 1 equal to x plus 2 by 10 gx dx. Okay, what is gx dx? Fx equal to gx dx, gx equal to dfx by dx equal to 0. If I start with gx as 0, answer is 0. Where here it is 1, here it is 0. We will add by 1 because successive approximation, we will keep approximating it. Now it is 1. We'll try 1 dx. It will come as x. X to x plus 2 by 10. It will come as 2 by 10. Wanted is 1. We are getting 2 by 10. So whatever we had taken, we have to multiply it by 10 by 2. So we will start with 10 by 2. Gx at 10 by 2. We will start again. 10 by 2 dx, that will come at 10 by 2 outside x, and x to x plus 2 by 10, that will come as 2 by 10. 10 by 2 into 2 by 10 is indeed 1. So we got the dx. Dx is 10 by 2. If it is 10 by 2, to now if I take any x fx, then that is same as x plus 2 by 10 gx dx. If I add all the gx dx, we will get full gx dx, and that is the addition of all the vertical in fx. Okay, but limit would go from x equal to 1 to whatever n is the last point plus 2 by 10. So integration x equal to 1 to n plus 2 by 10 gx dx. That will be summation of all 1 positive 1. So that will come as how much? 10 by 2 outside dx is 1, or 10 by 2 dx. 10 by 2 I can take outside, x is the result. Now it will go from 1 to n plus 2 by 10. So n plus 2 by 10 minus 1. This is the result. This is what it will be, the summation, whatever n we take. N plus 2 by 10 minus 1. Okay, now we will do with all the negative number. Negative number is same thing. Fx is 1, and it will again go 2 gap. It will start at 1 plus 1 by 10. 1 plus 1 by 10 for where negative will start, and it will go 2 gap. Let's take any n value here where this n is different than the last n. Makes sense? If I take any x equal to n, then positive n will be either 1 less or 1 more, because this is negative n. Positive n start from 1 and 2 to get 1, and then 1 plus 2 by 10, 1 plus 4 by 10, and so on. It will go up to n. Then negative x will start at 1 plus 1 by 10, 1 plus 3 by 10, and so on. And it will go to another n. N are different in both places. Okay, if I take any n value of x, then for positive, if it is n, then for negative, either it will be 1 less and 1 more. Makes sense? So this n is different. So here we will do fx equal to x to x plus 2 by 10, because 2 is gap. X to x plus 2 by 10 gx dx. At the end, gx will come same thing, 10 by 2. We'll start 10 by 2 dx, but integration limit will start from 1 plus 1 by 10. 1 plus 1 by 10. Makes sense? 1 plus 1 by 10, and it will go to n, n, n plus 2 by 10. Whatever n we are taking, one more, n plus 2 by 10. 1 plus 1 by 10 to n plus 2 by 10. So net it will come as 10 by 2 is anyway waiting outside, n plus 1 by 10 minus 2 by 10. Okay, now we have to add both parts. Okay, first part came as n plus 2 by 10 minus 1. That's it. N plus 2 by 10 minus 1. I have not tried actually earlier. Let's see if result is coming or not. N plus 2 by 10 minus 1. Minus whatever we are getting in bracket, n plus 2 by 10 minus 1 plus 1 by 10. Make sure the both n are different. First n is, we can say that is a positive 1 n, and another is negative n. But as per Sir Grandi, n tends to infinity. If n tends to infinity, then both n we can take as same, because it is infinity. So since it is infinity, we can take both as same, no problem. So that is the crucial part, most crucial part. So we can start n plus 2 by 10 minus 1 minus n minus 2 by 10, all gone. N plus 2 by 10 this side and n plus 2 by 10 that side, both cancel each other. This side we have minus 1. Now this side we have 1 minus 1 minus 1. This side we have 1 minus, oh, sorry, 1 plus 1 by 10. 1 plus 1, the bottom, up. I'll try again. For the minus stuff, what we calculated, it came as n plus 2 by 10 minus in bracket 1 plus 1 by 10. Makes sense? This side we have 1 plus n plus 2 by 10 minus 1. N plus 2 by 10, n plus 2 by 10 gone. Now this side we have minus 1 minus, and this side we have minus 1. If I settle down this one, that will come as minus 1 minus 1 by 10. Outside minus is waiting. Plus 1 plus 1 by 10. Makes sense? Now we have this side minus 1 and this side 1 plus 1 by 10. 1 minus 1 gone. Answer is 1 by 10, where outside 10 by 2 is waiting. 10 by 2 into 1 by 10 is exactly 1 by 2. So we got the solution. 1 by 2 is the answer. If it is difficult to understand, then please watch our previous video that gives the exact answer. But deliberately I took it because integral calculus is not confined to the x equal to 1, 2, 3, 4, 5, 6 we have to take. We can take any x. We can divide in 10 part, 2, 20 part, 100 part, 2 part, 3 part. But limit we have to take very carefully while calculating the sub area to get the gx. And once I get the gx, to calculate the final summation, then this limit value has to be taken very carefully. Now enjoy. Only thing we have taken. Now someone would intercept here. Now someone would say you have taken value correct, but n at both locations are different. Consider the last point is n, and that n belongs to positive one, not to negative one. Then negative one n will be n minus 1. So right now we have 10 by 2, that is outside waiting. We will keep as it is. Now for all the positive number addition, we have n plus 2 by 10 minus 1, where n is we have taken as a reference for the positive number. If I take negative number, then it is n plus 2 by 10 minus in bracket 1 plus 1 by 10. From there it starts. Now this side n will be this n minus 1. I believe it is understandable. If I see the actual problem, then actual problem is 1 minus 1 plus 1 minus 1 plus 1 minus 1. All the plus 1 we took into one side. All the minus 1 we took on the other side. All the plus 1, if I say, then consider 1, 1, 1, 1 is there on the x-axis, and it starts at x equal to 1. Their fx is 1. Now between x equal to 1 and 2, I cut it into 10 parts. 2 to 3 I cut into 10 parts. 3 to 4 I cut into 10 parts, in that manner. Now first one is at x equal to 1. Next is at x 1 plus 2 by 10. 1 plus 4 by 10, and so on. So on. If I talk about negative 1, then they will start at 1 plus 1 by 10, 1 plus 3 by 10, 1 plus 5 by 10, and so on. Now for all the positive, now consider the last number is positive 1. It is infinite, that is true, but last number is n is positive number. In that manner, for positive number we have calculated the summation is 10 by 2 into, and then n plus 2 by 10 minus 1. Makes sense? 10 by 2 into in bracket n plus 2 by 10 minus 1, where n n is any x value. X value starts from 1, 1 plus 1 by 10, 1 plus 2 by 10, 1 plus 10 by 10, that is 2, 2 plus 1 by 10, and so on. Where this n value that belongs to x axis and their vertical is 1, not minus 1. Then we have 10 by 2 into in bracket n plus 2 by 10 minus 1. Next. Now, for the negative number, we again calculated, keeping negative outside. It is n plus 2 by 10, same thing, minus from where it started. So, negative number will start 1 after the first one. 1 minus 1 plus 1 minus 1 will start after that. So, minus in bracket 1 plus 1 by 10. This is what we have settled down. If I say the last number is positive, then we will take as it is for the positive number, that is 10 by 2 into in bracket n plus 2 by 10 minus 1 minus, and then for the negative numbers n will be 1 less than what we had taken from n here. Then it will come as n minus 1. Hope it will be 1 less. So if I take 1 less, then it will be 1 by 10 less, because we have divided into 10 parts. So it will, earlier it is n plus 2 by 10. N will be replaced by n minus 1 by 10. So n minus 1 by 10 plus 2 by 10. That will come as n plus 1 by 10 minus in bracket again 1 plus 1 by 10. We will settle it down here only. N plus 1 by 10 minus 1 minus 1 by 10. So both cut each other and it becomes n minus 1. N minus 1. So n minus 1, where n is the last number where it is positive. Now we will settle it down. So it is n plus 2 by 10 minus 1 minus n plus 1. Minus minus plus 1. N gone, it becomes 2 by 10 minus 1 plus 1. It will come as 2 by 10. And this side 10 by 2, it will come as 1. That is perfect. Because if I have the last number as 1, then summation will be 1. Someone will say last number is minus 1, then it should come 0. Yeah, we will try. If it is coming 0 and if we take right hand side and n as reference, because last number is minus 1, then first n will become first n will become n minus 1, because it is 1 less. We try 10 by 2 and in bracket n plus 2 by 10 minus 1, n will be replaced by n minus 1. Sorry, n minus 1 by 10. So n minus 1 by 10 plus 2 by 10, it will become n plus 1 by 10. N plus 1 by 10 minus 1. Makes sense. N plus 1 by 10, n plus 1 by 10 minus 1. Minus, and that side it will become as it is, n plus 2 by 10 minus in bracket 1 plus 1 by 10. We will settle it down. N plus 2 by 10 minus 1 minus 1 by 10. N plus 1 by 10 minus 1. This side we have n plus 1 by 10 minus 1 and then minus in bracket n plus 1 by 10 minus 1. Same thing. Negative will be 0. So answer is 0. So answer is either 1 or 0 if I know last n is 1 or 0. But if n tends to infinity, if I consider n tends to infinity, then both n we have to take exactly same. That's why it is tends to infinity. In that manner, it will come as the way we calculated 10 by 2 into n plus 2 by 10 minus 1 minus and then n by n plus 2 by 10 minus and then 1 plus 1 by 2. If I settle down, it will become n plus 1 by 10 minus 1. Here we have n plus 2 by 10 minus 1 and here we have n plus 1 by 10 minus 1. If I subtract, it will become at the end 2 by 10 minus 1 by 10. 1 by 10. Outside 10 by 2 is waiting. 10 by 2 into 1 by 10 is 1 by 2 only. Perfect, amazing. This is the result that we can expect to come 1 by 2. This is what Sir Grandi has also suggested, that 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 up to infinity will be 1 by 2. Neither it will be 0 nor it will be 1. Okay. I believe this is understandable. Okay, we will try other measurements also. Probably I would not take 10 division because that would be cumbersome, but we will take two other kind of area. The concept is if I have x equal to 1, 2, 3, 4, 5, 6, then at x equal to x, I have function over x that is either 1, minus 1, 1, minus 1, 1, minus 1. We have segregated all plus in one side and one all minus in one side. And then if I say we have values at x equal to 1, 2, 3, 4, 5, 6, then all plus would appear at odd number of x equal to 1, 3, 5, 7, 9. There the positive 1 will appear, whereas negative 1 will appear at x equal to 2, 4, 6. All the even number of indexes on x-axis. So there the negative numbers would appear. If I segregate then on x-axis, for odd number of x, we have all the positive number. And for even number of x equal to 2, 4 like that, I have negative number. Okay, for addition of odd number of x, fx, now we have summation fx equal to 1 to n fx. Sigma x equal to 1 to n fx will give where x will jump 1 1 x equal to 1 3 5 7. This will give the summation of all the positive. If I want the summation of all the negative, summation sigma x equal to 2 2 2 to n, where n will go to x, where that is a even number, x equal to 2 to n. Earlier it was x equal to 1 to n, now it is 2 to n, where fx will jump 2 4 6 like that at x equal to 2 4 6. Everywhere it is minus 1. Okay, now in that manner, now if I calculate at any x, now let's see if we calculate the even number. If I calculate the odd places first, means positive number first. If I take any x equal to x, then fx is 1. This 1 will be same as if I calculate the area from this to minus this, that will go and hit gx. What I'm trying to say is fx at x equal to x will be same as limit x equal to x minus 2 to x dx dx. If I find it, then we have left hand side area that is equal to value is equal to the right side fx. This is second case. Third case is can I take, if this is x equal to x and I have fx, the left hand side 1 and right hand side 1, because net gap must be 2. Fx equal to x minus 1 to x plus 1. We will try all those and we will see result must come as 1 by 2. If it comes at 1 by 2, then it solves our assumption that actually successive approximation indeed it solved the summation series. So that we will see it is not available in any of the book. Anyone can try. Please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number. Okay.